So good morning, everybody, and a warm welcome to this technology and tools session. I think the main theme in this session is supporting workflows. And my name is Andreas Höhne. I'm part of the Competence Center of SDI in Baden-Württemberg, so in the south of Germany, and part of the SDI in Germany. And a few rules, I think the speakers know them already. I want to look a little bit on time, so you have 15 minutes and a little bit plus for discussion, and let's see how far we can go then. And people from the audience, they get a microphone, and so everybody can understand the question well. And probably afterwards will be some time for discussion also. The whole session will be on video, and we asked already the speakers for their for a form so that we can use the video, and the video will be on the platform afterwards. So the first speaker is on the presentation on integrated and automated Inspire processes from data update to Inspire service, and presented by Helmut Stepan from Moss Computer. So go ahead. Thank you.
Thanks. Oops. It's in French, can you?
Oops, sorry.
No, not this stuff. Sorry. So, my name is Helmut Stepan from Moss Computer Graphic GmbH in Munich, Bavaria. Perhaps you will hear it. I am pleased to welcome you to my presentation, Integrating Inspire into One-Step Flow. My presentation is very much based on practical implementation, because I think it's high time to establish Inspire into a local infrastructure. In this case, it is LVGL Saarland, Land Office for Surveying, Geoinformation and Land Development of Federal State of Saarland. It's a practical thing there. First of all, I'm not a technical expert. I was only the project manager of this workflow. And at the start of this project, I didn't know really what Inspire means. And I'm not quite sure whether I know it better when I leave the conference. So, but it doesn't matter. I'm looking forward to retire, so I'm quite relaxed. So, providing continuously up-to-date Inspire datasets require a high degree of automation, especially on the themes of Annex 2 and Annex 3. With the dynamic, such automation is the only way to enable costs effective. The idea is to minimize the delay between the internal availability of information and its availability via Inspire mechanisms. And I will show it in practice. I hope so. A short look at our company. I think you should know where I come from. Moss is a solution provider, founded 1987 in Munich, and we have offices in Essen, Dresden, and the headquarters is in Munich. We have about 60 employees. our main topics are data management for cities, regions, and countries with geotopographical data, especially focus on 3D, and environmental data. We process implementation and automatization, including third-party products. And we do, of course, individual applications and web mapping services. In this speech, the name Nova Factory and Vega will often be mentioned. These are two main products of our company, and they play a central role in the workflow, you will see. And so I would like to introduce both tools briefly. Let's start with Nova Factory. Nova Factory is an advanced spatial data management solution to administrate spatial data. Nova Factory controls and monitors your data process from the start until the end. It works with internal and external databases and integrates external systems into the monitoring. Nova Factory distributes the data according to customer requirements regarding to data format transformation or area selection. It's a tool for production, processing, distribution, visualization, and raster vector transformation. And as an example, here's a template for an export job in which the user can define his export parameters for a specific product. For example, for the output format, he can choose the spatial reference, the resolution, and some more user-specific parameters. And the next picture is a schematic scheme overview of how Nova Factory is placed in a local infrastructure. Nova Factory consists of an administration user interface, workflow process control manager, database connectors to our own databases, for example, a 3D GDI database, or optionally external databases. There are batch processing and batch monitoring, including external systems like Hail or FME. And it provides, of course, GDI services and has a variety of modules for different topics, also and especially for mass data processing. Here's an overview of available modules for Nova Factory. Nova Factory can be configured by the user for his own individual needs. Each module can stand alone, but communicates via the Nova Factory administrator client with his external and internal environment. Here I would like to highlight only two modules, the Web OGC service and as an example, the Copernicus module to make satellite data easily accessible for the user. Of course, Nova Factory can also work with metadata. Nova Factory stores metadata per product and per sheet. Metadata are supplied as XML during import, and metadata output with export and can be formatted in a user-specific manner. And of course, it supports CSW. And I think it's special using metadata. The data values can be visualized with Vega, it's the other tool of Nova Factory, can be visualized graphically in Nova Factory. For example, if you want to see a flight image date. And metadata display via click in graphics, and you have, of course, a comfortable metadata search. The second tool is Vega. Nova Factory Vega. It's a client-based WebGIS with map navigation like Google. You can view WMS or WFS and ArcGIS server data sources, inserting your own data sources. Access Bing Maps and Google Maps. You can measure lines and areas. You can change your coordinate system. You have a go-to-locator service, and you can administrate rights and roles via a central administrator client. You have simple redlining and advanced redlining, which means that you can store it in a database. Here's a short overview of the user interface. And now I came to the practical part. In Saarland, there's a project called Geo Data Center. Environmental data from a wide range of sources are collected, violated, and made available across all departments of administration and World Wide Web. And Nova Factory monitors this wide range of environmental data sources. Nova Factory knows when data updating becoming necessary. Nova Factory can do it in certain time circles or when data sources give a request that new data are available automatically. If necessary, the data are reformatted and will be compatible with the target scheme. In some cases, therefore, external programs such as HAIL or FME may also be included, or any other external program can be included in the workflow process. The action is controlled by the Nova Factory process, and Nova Factory Administrator Client provides an overview of running and completed actions and jobs. You have always a control over your jobs and of the status of the workflow. And then, finally, the data are imported in the customer database. It was a principal workflow. In every workflow, it's the same doing. Okay. And finally, an example of how the workflow looks with an Inspire theme. A request is made for a specific Inspire topic to provide an update service. And here is Nova Factory Metadata via Nova Factory Vega. The Nova Factory metadata level allows the user to view the availability of Inspire topics. After selection of the area, a Nova Factory job is created, data or finished services are fetched. In this case, it's the administration data, so the 3A data, so it's mostly NAS data format. Again, all running processes can be followed via the administrator client. If necessary, Nova Factory Process Manager assigns an external service like HAIL or FME to create Inspire compliance. It will be done by an external program or an external service. In this case, HAIL creates an Inspire GML file, and under control by the Nova Factory Workflow Manager, Degree automatically do the import into a PostgreSQL database, and then the user has access via Degree instantly to the current service. In this case, it's a cadastral parcel service. And all is under control of Nova Factory. This was an example for a realized workflow including Inspire alignments. Of course, it can be used not only for Annex 1, also Annex 2 and Annex 3, especially Annex 2 and Annex 3, because the data are very different then. And finally, some words to the advantage and outlook of this constellation, and I think this topic should be true for most constellations where Inspire is integrated into local infrastructure. Raster vector conversion is fully supported, dynamic of Annex 2 and Annex 3 are covered, automated, time-controlled and event-controlled processes, individual user-oriented alignment of the process. The process business data and metadata in one workflow, and integration into a local infrastructure, and you have a wide range of tools are available. So 3D tools and raster tools, vector tools, NAS toolbox, and so on. Now I'm finished and want to thank you for your attention.
Thank you very much for this very interesting aspect. Are there any questions to Mr. Stepan? Okay, if nobody wants to put in question, I have one question. What would be one aspect of trigger this process of automated data update? What would be the aspect of if there is one change in one object, or?
No, the source data gives the request to Nova Factory when an update is useful, necessary. There's a file, it's a start file. He put the start file in a directory, and then Nova Factory monitors the directory, and when there's a data punkt start between, then Nova Factory puts the workflow into the database.
Okay.
What? Short question: what database system stands behind Nova Factory?
We have our own databases for 3D, and we support ArcGIS, SDE, or Postgres, Oracle. Yeah, that SDE is Oracle. In this case.
Okay. Any other question? Not so far. So thank you very much, Mr. Stepan. And the next speaker will be Mr. Stefan Maes from the TU Dresden, and his talk is about an integrated software architecture covering the complete data lifecycle from acquisition and management to publishing Inspire services. So it's your turn.
Yeah, thank you. I think my presentation fits quite well into this order because we, in our research project, which I'm going to talk about, we addressed quite similar issues than the previous presentation. So what we did in our research project was developing a research infrastructure for the scientists. So it's actually not having the Inspire background, but I think we addressed with our solution quite a lot of problems that also are relevant within the Inspire context. So yeah, in my presentation I'm going to talk about or give you a little bit of background knowledge about this research project and the developed platform that we created, and end up with the reasons or the parallels that we see are also relevant within the Inspire context. So, yeah, the work that we have done is coming from the Collabis project. That means collaborative early warning information systems for urban infrastructures. And within that picture, you see basically the environmental problem that we are going to, or that we address within this research project. That's a problem that we have in most of the German cities. The wastewater that we face within these cities is treated in a so-called combined wastewater management system. That means that the wastewater is coming from the humans and stormwater is combined within the sewage system and treated together in the wastewater treatment plant before it's actually going back into the rivers. And this is causing problems in cases of heavy rain events, because in that cases sometimes it happens that the wastewater treatment plant is no longer capable of handling all the huge amount of water. And in that case, it comes to a so-called combined sewer overflow. So partly the water has can no longer be treated and has to be put directly into the rivers, which is obviously not a very good situation because all the pollution is then also ending up in the rivers. So the aim of our research project is to improve that situation by getting more understanding of the whole pollution processes and the amounts of water or sewage water that we have in the system, and based on that provide the relevant stakeholders information about how to improve their management and mitigate the problems that we have within that. So possible stakeholders are, of course, the companies that are in control of the water discharges, but also the street cleanings, because we found out that the biggest amount of pollution actually comes from the traffic. So we also looked at the pollution coming from industry and the wash up from facades of the houses, but at least in Dresden the biggest amount comes from traffic, and that's particulate matter and heavy metal in particular that we are looking at. This is basically the workflow that we have within our project. I do not want to go into detail, and there's also no need for you to understand every single bit of it, but I just want to show that there is quite a lot of data that plays a role here. We have land use data, we have traffic data from different sources. We have real-time data that's coming from sensors that we put on the taps, on the cabs that are driving through Dresden. So that's real-time data. We have, of course, administrative data from about the street network. And we combine that with crowdsourcing data, and we have a couple of sensors that we have put in that are already existing in the sewage system and also in the rivers, that's basically teat gauges, to get information about the actual pollution. The scientists took samples at the streets. So as you see here in this picture, they used a kind of vacuum cleaner to take off the dirt from the street and analyze this then, or did a chemical analysis of the dirt to find out the amounts of heavy metal and particulate matter and those things within that dirt. And they also took samples from like filter elements they put into the sewage system, and all this data in the end is the basis for a simulation they run to find out the actual behavior of the pollution within certain spots in the sewage network. And the result of these simulations is a time series for each of the particular spots that they have, and based on that they can decide how to manage in the end. There are different options that a manager has within such a system. There are possibilities to store certain amounts of water in tanks in the sewage system, or they can in the end treat the water directly or discharge it into the rivers. So based on that, the manager has some information or data he can rely on when making decisions about these things. So in the end, we have a lot of different researchers from different disciplines working together in a quite complex workflow. And for us, there was the question how to support them by exchanging their data and doing the daily data management that's actually required for such a workflow. There are quite a lot of research management platforms to publish research data available. Here are only a few of them, but the problem, or actually the reason why we couldn't use one of them, was that most of them actually lack in supporting the workflow itself. So most of them are well suited to publish the final research results. So after actually the research has been finished, one can publish the data there, but the actual daily work, the research workflow that is basically the everyday work of the researcher is not supported by these platforms. And we wanted to address this. And another problem is for a researcher that every publication of data is coming with a lot of metadata tasks, which is something we actually wanted to keep away from our researchers, because otherwise they will not use such a platform. They do not like these tasks, obviously. Most of the research projects do not have a data management plan, and the researchers do not want to put a lot of effort into this. So that's why we try to keep our platform as simple as possible and easy to use. Yeah. So for these requirements, there was not a perfect solution in place. So that's why we designed, or based on already existing components also, an architecture which is shown here. So that's our Colabis research data platform. Has three basic components. The first one is seen on the left, the researchers' data management platform. This is basically the tool that the researchers use in their everyday work. And when it comes to publishing of the data, we have the two components on the right. First, it starts with metadata publishing in a CCAN, which basically is a search platform for data. And then when it comes to the actual publication of the data itself, we have the stack on the right side. The data management platform is, as I said, the central part for the work of the researcher. And of course, similar to the previous presentation, this is also kind of file manager, but it has much more functionalities in terms of how to collect, manage, and share data between the scientists. So this is supported. We have versioning supported. And the whole workflow of how to enrich data, update data is tracked. So also the metadata is updated. So there we try to keep with that as much as possible work away from the scientists. And we also have, as I have shown in the workflow, we have a lot of external data sources that we have to include here and integrate. And this can also be done within that platform. We have links to ATL tools. At the moment, this is relatively simple because most of our data is CVS, but of course, this could also be more complex, like HALE or FME interfaces, and yeah, this could be included within a workflow here as well. So when it comes to the publication, or actually the sharing of the research data, we use, as I said, CCAN. CCAN is open source catalog from mainstream IT actually, so it's not really, or not only usable for spatial data, but it supports geospatial metadata and of course CSW interface to provide the metadata as well. And yeah, so it has huge capabilities in terms of storage, discovery, indexing, and all these things are supported here. And we have built extensions to Geo server, so it's possible to provide the data via the OGC interfaces or services here as well. And of course, this could also be Inspire services here. And finally, to provide our data also to our stakeholders and have little applications, or like you see these little graphs here, we have a component to publish the data sources and in the end provide also early warning informations or alert services to our stakeholders. This directly links to CCAN, so the publication here is basically one workflow for the user. And yeah, as I said, the OGC services are supported. We have some REST services here as well, or service interfaces, and an IPE that allows to build applications on top of that. So what are the advantages of such a system for the researchers? In the end, for us as the developers, we come much closer to the researchers' daily work. We support them in what they are doing, and yeah, it's no longer just a publication of the final data. It's really a tool that they can use every day and support them. The data exchange between the different researchers and also between the different research institutions that are working in the project. Yeah, there are still a lot of metadata tasks, of course, because not everything we can take automatically out of the data, and not everything is just yeah, obvious when the system is capable of handling the workflow. So a lot of data still has to be input from the scientists, but in the end we can support this, or we can minimize these efforts a lot by just updating the existing metadata and also integrating this metadata acquisition into the workflow. We have some capabilities of semantic enrichment and transformation in the system, and this also helps to enrich the metadata information. So the whole workflow of data publication and metadata generation and publication is basically one workflow. The overall platform is not difficult to install, so this is also an issue for projects or people who do not have this background. So it's not difficult. Yeah, you can have a look at the platform and try it out when you go to this link. And all the three components are independent also in a way, so they can be used together, but it's also independent products that are open source, so they can also be connected to other tools as well. So finally, I want to stress a little why we think this is also relevant for the Inspire context. But I think coming after the first presentation, this is relatively obvious because we work on the same things. We want to, yeah, it's okay, it's the last slide. We want to get closer to the workflow, to the workflows that the people have before they actually publish their Inspire data. In our case, this is starting with the data acquisition, but in Inspire, it's probably more the data that's coming from the maybe municipality administrations to the higher order administrations where the data has to be integrated and then published. So this process should be supported right from the beginning. And this can be done with a seamless data management environment as I have shown here. And the biggest advantage, in my opinion, is the integrated metadata enrichment process. So we are keeping track of the metadata, and in the end, the publication of the data and the metadata is more or less one step. So there's not that much additional work to do. With such a system, we can keep track of the versioning, track the changes, and doing that, we can also observe the data provenance and put that into the metadata. That's another advantage. Yeah, thank you for your...
Thank you very much for this insight into this very complex project. Are there any questions to it? Could you please wait for the microphone? Thanks.
Excuse me. Yeah, just the component you were talking about, the research data integration part. So as it stands now, you mentioned possible integration with FME or Hail, but at the moment, was that mostly custom development that you did there?
I wouldn't call it like that because at the moment the transformation that we do are on CSV files, so it's relatively simple structure and we do not need a complex transformation system for that. But originally we had the idea to link to or to interface with those systems, and it's one of our tasks that we have open in the project. Yeah.
Okay, one question to the metadata. How do you create metadata? Comes this from the dynamic researches like the waste water you get from the traffic information?
Partly we take it from the services that provide us data. We have weather data, and I did not mention everything. So we try to just to keep as much of the metadata that we get from the data sources already. Partly we try to get it automatically from the data, for example, bounding boxes and those things, but I think it's not that much that you can actually get automatically. And yeah, and basic idea is just to update the existing metadata and put it on the next version in the end. So keeping track of the changes and not enforcing to reacquire it for every single step, or basically every day the researchers is uploading something.
Okay, any other question from the audience? Okay, thank you very much. So we come to the next speaker, and Mr. Steingordet here is talking about Inspire interoperability, roadmap, and architecture lessons learned.
You can go.
And we're looking forward to it.
Okay, thank you, Andreas. So good morning, everybody. So my name is indeed Stijn, and I work for GIM in Belgium. And so we did a small consulting study for the ACT, so the Luxembourgish mapping agency, on making sure that they meet the Inspire interoperability deadlines. And so I'm very happy also to be part of this session on workflows. The speakers before me have mentioned the use of FME to harmonize your data sets. But as I would like to show you, you can also use FME actually to automate your publication workflow, to update your metadata, to configure your view service and your download service and so on, just directly with FME. And you can schedule that also with FME server. So I've called this presentation Lessons Learned. So, but first, yes, a quick introduction to the ACT, so our client. So they are the National Mapping Agency. They maintain the National Cadastre. They maintain a differential GPS network. They have the country's national geoportal under their responsibilities. And interestingly, they also manage the country's open data portal. So in Luxembourg, things are very well organized, I found. And so actually the ACT is the sole responsible for Inspire data harmonization for the whole of Luxembourg. So there are more than 250 data sets in Luxembourg that are within scope of Inspire from 22 government agencies. So the ACT in the beginning of 2016 asked us to make kind of a plan, to make a roadmap, a 5-year roadmap, what it would take for Luxembourg to actually meet the Inspire interoperability deadlines. So they asked us to identify what needs to be done, who needs to do it, and what would be the effort required to do it. So I think it's very interesting to make a plan, just to prepare. And in the case of Luxembourg, because we could do this for the whole country, it actually was also a very useful exercise. And during this process, of course, we had many interviews with the data producers, and it also helped to increase the knowledge about Inspire and what is required from it. So they also asked us to review their application landscape. And so we made some choices, and we replaced some of their existing applications with open source components, where it's possible. So for example, for the metadata and the discovery service, GeoNetwork will be used or is already used. So for the view services, they switched from RGS for Inspire to GeoServer. Because we could demonstrate that you can use these open source components to have Inspire conform network services. Something we learned from the ACT, I would say, rather than the other way around, is that it's important with Inspire to keep things as simple as possible. And so just one example is that in the metadata, although the country has 3 official languages, they made a choice for English to document their data sets, because the target audience of Inspire data sets and services is an international audience, so that's why they've chosen for this language, and only this language, just not to overcomplicate matters. So on the metadata, you can make some other choices to simplify things, or just do the middle what is required by Inspire. Also on the download service, so the Inspire directive requires you to minimally have a predefined dataset download service, and where practicable, to have a direct access download service. So a predefined dataset download service, it's just a file download service. It's easy to put in place, but of course the user can only download an entire dataset, even if the user is only interested in a few features that are in that dataset. And so that's different with a direct access download service, where the user can really query and filter the features that are required. But Inspire actually only mandates that you have a file download service. So a direct access download service is actually optional in our interpretation. And so it was a choice was made so at the first, so to, in the beginning at least, not provide this direct access download service for simplicity. If there would be actual real demand and real user needs for such a service, then it could still be put in place. Just having a look at how to implement a file download service, the most difficult part is, so you need to make a file available for download, but the most difficult part is to have, according to the implementation guidelines, to have atom feeds and an open search interface for those file downloads. We have chosen to implement that with GeoNetwork. So GeoNetwork, so we made a small extension to the source code of GeoNetwork, which we hope to get into the core of GeoNetwork, to generate atom feeds just on the basis of the metadata that is already provided. So this means that if the user provides up-to-date metadata, then the atom feeds are generated dynamically. So this is easy to set in place, and GeoNetwork already supports the Inspire conform open search interface. So putting in place a file download service would be relatively easy, and it would also be easy to guarantee the quality of service that is required for Inspire. Going for a direct access download service is also possible. You could use, for example, the GeoServer application schema plugin for this, but it has some limitations. It requires also a little bit more work. It's a bit more difficult to guarantee quality of service, and for these reasons, we've decided that for now, it would be more wise not to provide this service. So another lesson learned is that it is, and this is also something we learned rather from the ACT, is that you can use Docker to really automate the deployment of the various components that you have. So ACT has Docker files or Docker images for FME server, for PostGIS, for GeoServer, for GeoNetwork, etc. And so all this allows them to quickly set up a development environment or to update it. It's really also a way of saving some effort and some budget. An important lesson learned is also to automate conformance testing. So you can very quickly overlook some of the technical requirements when you're implementing Inspire. And so for validating the metadata, we currently still use the Inspire GeoPortal validator. For validating datasets, we started to use the ETF web app with the Arena executable test suites. And then to validate the network services, at the moment we are still using the GDI-DE test suite, and we'll see how the other test suites evolve, whether that would change. So, but now on the workflows, something that we also learned is that it's very important to automate the publication process, especially in ACT, where you have, in the end, we will have more than 250 data sets to publish, and for which we need to provide also interoperable network services and metadata. So if you do not automate this process, sooner or later you're going to make a small mistake and you will not be conformant to the requirements. So it's possible to automate this because all the components that the ACT has in place for publishing Inspire also have APIs themselves. So the country's open data portal is used to actually upload the data sets and to make them available for download. It has an API. They use GeoServer. GeoServer has a good REST API to fully configure it using the API. The same goes for GeoNetwork. GeoNetwork implements transactional CSW, which means that you can also update metadata records automatically. And the validation test suites, such as the ETF Web App, also have their own REST API. So the first step in this workflow would just be to harmonize the data, and that's what most people know FME from, so you can use it to harmonize the data. Why? Because FME has this Inspire GML writer that allows you to write GML according to the built-in schemas of the 34 Inspire data teams. So, and it supports all the Inspire complexities that you have: multiple geometries, nested features, object referencing, repeated elements, syllable elements, and soon also grids. I'd like to see well, the work of Dean and on this. So this is on the output. So you can write Inspire conform GML. And so then the question is, when you read data from the source, how do you map that into the right schema? And for this, FME uses a transformer which is called the schema mapper. It actually allows you to restructure the schema of the existing data that you are reading on the input side, and you transform that to a new schema, the Inspire schema, based on mappings that you define in a table, in an external lookup table. And so here's an example of such a table. And it allows you to map feature types, so source and target feature types. It allows you to map attribute names, and also it allows you to map attribute values. So here's a simplified example of what a harmonization workflow could look like in FME. So you read the input data, you use the schema mapper to do the mappings. You use the attribute manager to do some calculations or apply some regular expressions. Reprojector to reproject to an Inspire conform coordinate reference system. You give a name to the geometry and you write it using the Inspire GML writer of FME. So there are very good tutorials on the knowledge platform of FME on this. So if you're interested, you can take a look there. They have been there since, I think, beginning of 2015. So, but they are still very relevant. So, but then you can also use FME for the other parts of the workflow. You can use it to upload your data sets. So in the case of Luxembourg, they have this U-Data, which is a piece of open source software that the French government actually uses for its national data portal. It also exists in Luxembourg. And so it has a very good API. And so in this case, we have used some Python code, which you can just put in your FME workspace to publish your data sets. Not only to upload the data set to the data portal, but also to update the data set metadata. And the idea here would be that you would read your metadata records from GeoNetwork, and that you actually use the same metadata or simplified version of that as the metadata record you would also have on the country's national data portal. So in this case, you would have full consistency between all the metadata. So this is kind of an advantage. And also, people indeed do not really like metadata and to update that. So the more you can automate, the better and the happier, I'd say. You can also use FME to configure view services on GeoServer. So Yeah, in this case, FME has also this general purpose REST client, which is called the HTTP caller. You can configure that, and so in the case of GeoServer, you can send, you can make HTTP requests for HTTP post or put, and send some XML configuration data along with it, just to make sure that you either create or update the right feature types and give the right layer information to GeoServer. So then next part in the workflow is also to update the metadata records you would have on GeoNetwork, so that you have your Inspire conform metadata records for the dataset metadata, but also for the metadata of the services. So a quick example here. So in this case, the existing metadata record is given as an input. You want to update the timestamps that are in the metadata record. So you can use an xquery updater. So you can use an xquery to actually update the metadata record and provide new value for the timestamp. You can also use xquery to update the online resources, because as you have just uploaded a new data set on the data portal, actually what you have is a new URL. And so you should update the online resources of your dataset metadata. The same goes for a link to the capabilities document of your view service. That's another online resource that you could update here. And in the end, what you do is using this HTTP caller to post actually to the CSWT endpoint the updated metadata record. Last step is actually to automate the conformance checks. 2 minutes left. So, well, ETF Web App, for example, also has an API, and you can automate conformity testing also in you can put that in your workflow, so which is very useful. So as a wrap up, just the lessons learned, and I would be happy to take your questions. Thank you.
So thank you very much on this Vega on the whole Inspire workflow. Are there any questions to the speaker? Yes, please. And there's another one, but yeah, please go ahead.
Very quick one, actually.
Yeah.
Yeah, thanks a lot. Just where was the most work in this process, the most hours, would you say? That's the simple question.
Well, I would say most work is in figuring out the metadata. So the metadata, the implementation of the atom feeds, to get that right. But it's worthwhile to put that effort in, especially if you do this for one whole country. So everything is automated now. There are many. So doing the metadata work and everything around it, so configuring your network services correctly, to me seemed more work than actually the actual data harmonization. So that's you can do that fairly quickly, I would say, at least for the Annex 1 data sets that have been harmonized so far. So, okay.
There's another question.
Thank you. Interesting presentation. I think 250 metadata sets, data sets is something others dream of, having only such few. The question is towards your updating process. You said that you would then generate a new metadata entry for your data set once you update your data sets. Do you have any idea about versioning or having temporality in that? Any plan for that?
It's a good question. So it's not required. So we just provide the latest. So we update the metadata records only. So they must exist for these data sets. It's updated, but we don't keep versioning. Of course, tools like GeoNetwork allow you actually to also version your metadata records. If I recall, there's an SVN solution behind it, but it's not required. And so that's also why we would not do it. So the implementation here also has this philosophy of, unless a user really wants it, or unless there's a real need for it, we're not going to do it. So, and I think that's, the right attitude. So, okay. Okay.
Okay, no other question. Thanks again, very impressive. We come to the next presentation. Nicolas Aukerman and Timo Merkel, they split this presentation. Yeah, and okay. And the presentation is on GDI-DE or SDI-DE and Inspire Bridge Schleswig-Holstein and a practical view on Inspire implementation. Okay.
Yeah, thank you very much. First of all, my name is Nicolas Aukerman. I'm from the Coordination Office SDI Germany. And I'm very thankful, very happy that we have this presentation here today. It's a special presentation for me because I do it together with my colleagues from Schleswig-Holstein, SDI Schleswig-Holstein, and that's where I used to work last year. And I have some stakes, some involvement into this development that we are presenting right now. But now I have a different employer, so I will just do the an outline, an introduction to the topic, and then hand over to my colleague Timo Merkel. What do we want to talk about? We want to talk about practical implementation of Inspire, and I'd like to start with a quote just to set up the scene. You all know the 2016 report from the EU Commission, and it seems that we have in practical implementation some problems, some issues. Member states mentioned that they have some difficulties to achieve harmonization, and especially the transformation of existing data sets into the requirements of Inspire seems to be a problem. And I would like just to rethink the problem that we might have there, that the data owners, the authorities, the administrations might have here. Inspire itself, the principle is quite simple. We have a source data set here illustrated on the left, and we have to transform it with a tool, and then we have an Inspire data set. We have to publish it as download service, view service, catalog service, whatever. Quite simple principle. Now, as we have in practice the problem that we have many data owners, we have many people involved in this process, we have a situation like this. We have loads of data sets, we have different tools and softwares that, for transformation. We have different Inspire data sets, different specifications, and in the end we have several possibilities to publish services, many tools. And of course, in the practice, you require a lot of knowledge and a lot of effort, a lot of time to solve this problem as a data owner. So remember this situation. It might be one municipality that has data from different themes, and they have to solve this for each theme, for each data set. Now remember the situation in Germany. We have a federal state. We have federal states. We have one nation with the highest level in the hierarchy, with one parliament, one legislature, etc. And then we have 16 federal states or Bundesländer. Within these Bundesländer, we have more than 14,000 municipalities, and each municipality, each data owner has to deal with the situation mentioned before. So the tricky situation is that each federal state in Germany has its own implementation of the Inspire directive. So it's not, there is one national law, but the federal states have their own laws as well, because this is done by the states. It's not done by the nation. So we have different approaches to achieve the Inspire goals. For example, we have central implementation versus local implementation, and we have a varied picture of Inspire data sets and services. Just to illustrate this, in my office now, the coordination office of the SDI Germany is situated in Hessen, a small Bundesland in the center, in the heart of Germany. And I would just like to illustrate how the situation is there. We have 5 independent cities, we have 21 districts, and we have 426 municipalities, and this is just a small federal state of Hessen. So we have, of course, other states that have other situations. We have city-states. We have, for example, like the local level is not existent because it's also a federal state, Hamburg or Berlin. And we have huge aerial states like Bavaria, or we have other small federal states like Schleswig-Holstein, which, by the way, is, I don't know if you know, it's situated in the north, so the most northern part of Germany. And so this leads us to the problem that we have challenges to overcome in the practice. We have the different approaches within the states with the right picture of data sets and services. And these different laws bring the problematic that there are, bring the problem that there are slightly different legal bases. So sometimes the local level is involved into the law, so it has to provide inspired data. Sometimes it's not. And there's no national coverage that we can achieve with specific data sets. All in all, we have within the states, within the municipalities, on all levels, we have lack of resources, of course, and a lack of know-how for the data owners, especially at local levels. So it's a huge technical challenge. And this, of course, we have on a national level, and we also have then on the federal level. And there comes the Inspire Bridge, a development of Schleswig-Holstein, which tries to deal with this problem on a Schleswig-Holstein level. And at this point, I would like to hand over to my colleague, Timo Merkel.
Okay, yes, thank you very much, and good morning, everyone. First of all, I will not get further into technical details about software, but I will we use standard software and mainly FME server, and I will get more into methodology themes. So first of all, our focus is how can we manage Inspire within Schleswig-Holstein. And as you all know, Inspire is quite a complex undertaking. And as Nicolas already pointed out, Inspire concerns many different organizations in different hierarchies. And as a consequence of this, we have many different people involved. We have just a few experts. And we have as well many data models. So, and as our financial and personal resources are limited, we have to look upon things from a practical and economical way, which means we have to keep it simple. Our solution is the Inspire Bridge, which is much more than just a technical solution. One main issue is to identify the Inspire-related spatial data and as well as to create migration sheets. And for this purpose, we initiate so-called field network groups for the different annex themes. And these groups consist of different domain experts and as well as technical and administration experts and field network leader. And we face the problem to deal with, to have just a few experts to do the work of identifying the data and also creating pre-standards, as I will tell, for the rest of the users within the federal state. And as the data structure is very heterogeneous and we have a huge amount of data, we have to create pre-standards in order to use automated workflows. And this is just our point. So this is our technical solution, which is the Inspire Bridge. That is a central platform where the costs and services can be bundled in an economic way. And however, the responsibility for the data still remains at the data owner. So he decides what will happen to the data and how others are allowed to use the data. Let's have a closer look on the Inspire Bridge itself. It is a web-based user interface and is developed with HTML5 technology on one side, and on the other hand we have server-sided ETL technology. The Inspire Bridge allows an easy-to-use workflow for uploading, for editing and adding metadata, as well as quality check and transform the pre-standard data into Inspire conformal services. And as you can see on the screenshot, the workflow is structured according to a certain user and a certain NX theme. However, for a first use, there has to be done an initial implementation, which is done by setting up the user data and as well as the pre-standard data, and the transformation and quality check workflows has to be installed on the bridge as well. In the end, the Inspire bridge will provide a fully automated workflow where the user interaction is reduced to just a minimum. This is how the general workflow looks like. So first, the user has to upload his data. This is how it looks like from the user's perspective. The user selects a file and enters a file name as well as a description, and by clicking on the upload button, the data will be directly uploaded to the central server. And at this step, the data is automatically assigned to the particular data model, and a quality check is executed. Let me shortly demonstrate this with a clip, how this looks like from the user's perspective. Hopefully it works. So, first the user selects the data set he wants to quality check and transform. And by clicking on the execution button, the quality check will be executed, and after just a few seconds, the user receives a quality check report down on the button, and get a transformation notification that the transformation has been started, has been scheduled. So if the quality check fails, the whole process will be aborted at this point. Otherwise, the transformation will start, and the dataset will be converted into Inspire conformal data and saved into a shadow database. And as the transformation may require some time and some processing power, this step is done asynchronously and scheduled by the server. And in the final step, the user has the ability to check the transformed data using services on the shadow database. I will show how this looks like. The user selects one of the transformed data sets and gets a short description and a description about the transformation result. And down on the bottom, there is links to download and view services, so he can recheck the data. And if everything is okay, the user selects presses the release button, and the data is directly saved into the production database, and the services are updated. So this is our main workflow. As you saw or can see, we have successfully created the environment for automatic processing of many different data formats with the help of pre-standards. So our further development will be the development of further pre-standards, as well as processing workflows, as well as to do some minor optimizations. And another big issue is that we want to harmonize Inspire-related data, which means in the end we want to have just one service per NX where it is possible. Another point is that we want to enable service-based data input in addition to file-based data input, what I just showed to you. And we want to support web feature services and web coverage services. And as our Inspire Bridge is in-house developed, we would be very happy if we could find some other federal agencies to cooperate and share out our application and experience. So feel free to contact us. And yes, our main goal will be to create surplus values beyond Inspire aspects. This means we are working on harmonizing data within the SDI of Schleswig-Holstein, because as you know, proper spatial data is a key component for digital governmental work and economic growth. So at this point, I would like to thank every parties involved from the SDI of Germany and Schleswig-Holstein, as well as our technology partners, and thank you for your attention.
So thank you very much for your information. And are there any questions from the audience? This is not the case so far. I have, or is there one? No. Okay. I have probably I missed something, so excuse me in advance. Once you transformed, or once a city or so has transformed its data, who's the provider for the services?
The providers is the central coordination office.
Okay.
The system. It's a central server. Yeah.
All right. Okay. And are there already some potential users for that?
We have some potential users. I have to excuse me because I'm not quite in this topic, but I'm more the technical developer.
All right.
So, but yes, we have some first.
Maybe you can give an answer to that.
Yeah. At the moment, we are still in the doing process. We're looking for the Annex 1 themes. Thank you very much. So we are still in contact with the municipalities in Schleswig-Holstein. This is very interesting because of the transportation network, also for the protected sites. And we are in very good contact to our environmental state. So for us it was eminent to do a central platform because otherwise everyone had to do the work on its own. And you see our intention was to look at the platform, not to look at the technical part of transformation. We just have to do it. This is a thing we can't escape for. But I think this is a very good point of starting to get a very good spatial data in the SDI, and this is the point we are looking for. Thank you.
Thank you very much. So thank you all for this presentation and answering the questions. The next speaker is Thorsten Reitz from WeTransform, and he's talking on can we make complex easy? Hopefully yes. A sneak preview at the next generation of data transformation tools. We're looking forward to your presentation.
Yeah, thank you very much. Yeah, good morning everybody. Thanks for sticking through with the last presentation. Yeah, so one thing that I personally have been dealing with is basically this question about what makes, in some cases, data harmonization a hard task to achieve and all the transformation related to that, and what can we do about that? And yeah, there are some aspects that I would like to highlight. Three are related, or these three are related to current development that we do. And I thought it would be interesting for you to see what kind of things we as a company mostly involved in data transformation are currently working on and will be doing in the next year or so. The three topics that are currently high on our agenda are cloud transformation, collaborative development of transformation projects, and new paradigms for transformation definition. So basically, do we always have to do it in the same way, or are there also other ways that might make things a bit easier for us? Yeah, so first of all, one step back. Before I delve into the technical specifics, I would like to briefly explain again how our software works. That means Hail Studio and the other packages that we've developed. At the core is the idea that when you work with the software, you should mostly declare your intent. So basically saying things like, I want my tree to become a habitat object, for example. So you always reference directly something from your source model to something in your target model. You do that at all levels in as complex a data structure as you want to. So for example, you say, okay, this should be retyped, and then the different properties should be renamed. There should be calculations, geometric functions, and so on. This has several advantages, the main ones being that it's relatively easy to author and reuse. So in particular, when you're dealing with complex data structures, this enables you to just deeply go into any data structure, and the tools will create everything that you need automatically. It also means that you have usually fast and scalable execution, because each of these individual functions can be also executed individually. And it works with any data structure and format. So yesterday I presented about how we use one set of alignments to actually transform both from XML to XML, from databases to XML, and many other ways. Yeah. The current state where we've implemented this approach is on the one hand in the open source software Hail Studio, and on the other hand in our cloud software Hail Connect. And so I would like to highlight now the three aspects that I mentioned in the beginning. First thing is, we've just heard how important cooperation actually is, and I think that's true. Yeah, if they have 7,000 or 8,000 Inspire organizations, all of which do the same thing by themselves, nobody can really profit well from what the others have been doing. So what we think is really important is to have the ability to share solutions, partial solutions with others, so that they can quickly learn from that, adopt what they can, and then just add the differential more or less. And for collaborative discussions, there's a couple of features that we've added. So one, for example, is that in the last projects that we've done, we found it's important that you establish a clear context. So when somebody says, yeah, that particular part doesn't really work as I expected, that we can actually document and have that discussion right there on that particular function. So that means especially this documentation form that Hail Studio also provides, where you really look at each individual relation. We found that that's something that really helps domain users a lot to evaluate what's actually going on in the transformation, and to tell us or to find out by themselves whether it's the right thing, whether it's what they expected. And if it's not, they can actually say so right here on the level of the individual relationship, for example. This can also be versioned. So basically another thing that we had in a couple of projects is, let's say, going back and forth. So there's, you can probably imagine if you can't really clearly version the project that you're working on, things will happen that you're going back and forth and you're not sure which version was the one that actually worked. So one thing that we've also enabled is to actually be able to really track all changes that are made and to show these again on each individual relationship. One thing that you can do very well with that is also to deal with migrations on the schema side. So your database system is changing, no problem, you make a new version. Or your target schema, like there will be an Inspire 5.0 schema someday. It's also supported to migrate to that. Yeah, it's actually based on a Git backend that can also be accessed via Git, so that might be helpful in some cases as well. And then to build on both of these things, actually there's a kind of a similar workflow to what some of you might know from GitHub, where you can take some source code, fork it, so you basically create your own copy or a branch, make your changes in that, and then propose that as a solution via a pull request. And there's a similar workflow here where you create a task, you basically say this needs to be changed, people can make a proposal how to fix it. Let's say, for example, how to concretely implement a specific geometry pattern in Inspire, and then if you have the solution, you can say, okay, yeah, that one should work, so I'll accept it. Yeah, that was the collaboration. So we actually have quite a few more things in that area, like being able to reuse projects that others have made and so on. So if you'd like to know more about that, then feel free to ask questions later. The second thing that we've been working on is, to really use, we are building an infrastructure, right? So much of the data that we're dealing with is actually in services online. And to always have to execute the transformation locally on my computer means that I have to get all the data originally to my computer, then do something on it, and then again, send something up, which might not be the most efficient way. So what we've added is actually a cloud transformation capability. The idea is to, on the one hand, be able to process large data sets really fast. So you might know that Hail has this real-time data preview whenever you make a transformation. That's somewhat limited in the amount of data that you can currently process really fast, like in 1 to 3 seconds. And if we actually use the cloud, we can work with much more data as a sample for our live testing. We also want to be able to transform many, many data sets in parallel, for example. And like I mentioned before, if the data is already online, it makes perfect sense to also do the transformation there. So this is available now. We've deployed that. We're not yet sure, as part of Hail Connect, we're not yet sure if this also has a separate product existence in front of it. We'll see about that. Yeah, just very briefly on the technical aspects, it's kind of similar. You've probably heard about Docker by now. Many of the technical people just very much like it. In our case, the public cloud deployment that we do is on an EC2 container servers cluster, where we can automatically deploy basically as many images as we need. The current cluster that we're using consists of 4 instances with each one being able to do up to 2 processes, and that's basically available as a fully transparent engine. So when you do a transformation, for example, in Hail Connect online, it will happen on this cluster without you noticing. Yeah, it was kind of an interesting challenge to set up everything like that. So we had to use a lot of different parts of what the Amazon Web Services environment offers. For example, using Amazon CloudWatch events to scale up and down, to use Lambda functions to execute many small parts. But there's such a lot of capabilities today in the cloud that really helps one to build up complex, let's say cluster-like environments that really scale with demand and with other factors. That even though there is a certain effort involved, it's still much, much easier than it used to be. Yeah, there's also, for example, things that we had to implement is on-demand mode, also making sure, because some transformations can run quite long. So if we have a data set with tens or hundreds of gigabytes, you don't want that instance that runs there to all of a sudden be shut down. So yeah, things like that also have to be taken into account. Yeah, we've seen similar things about how this is actually done before. So there's the way to define the cloud resources that you need for this definition and permissions in deployment descriptors. To basically deploy all of that automatically on any change. So we often deploy daily, can actually be done also automatically here. Yeah. So that's all the stuff that you don't see when you do the transformation, and that's a part of why the complexity should be hidden. So, like I said, there is all this work that needs to go into making a large-scale cloud transformation work, but in the end, it's completely transparent. And even from Hail Studio, it will be possible to use that without you noticing in any way. Yeah, the final part is the user interface. So in the user interface, many of you probably know Hail. Like I said, the core idea at this point is that you select elements from a source schema in a tree-like view and from a target schema, and you, based on the selection that you've made, you pick an appropriate transformation function. That works quite well in most cases, especially when you have an object-oriented model. Because what Hail actually does is it can take into account the inheritance structure, so that if something is defined in a top class, you only need to map it on that class, not on everything below. However, not all data models are object-oriented models, and even some object-oriented models gave us some headaches. So one thing that we're currently working on are so-called aspect mappings, where we don't select concrete objects in the source or target anymore, but rather determine define a pattern, like for example everything that has the name or that has a certain type, like anything derived from geometry, is then actually falling under a single definition. And that enables us to make some especially repetitive mappings much smaller. So I've in the screenshot here I have one of the RDV projects, the geographical names one. And as you can maybe guess from the right-hand side, it looks a lot like there's always the same stuff in here. And yes, there's always the same stuff in here. So that's one of the things that we really wanted to simplify here. Yeah, and then there's a couple of things that I would say at this point are mostly done on research. So we have several research projects going on that really evaluate how we can change the interface entirely. The objective basically is that I'm assuming that we will see more and more touch interfaces, and we are looking at a next generation of how to define a transformation, maybe not on your phone, but for sure on a small tablet. That should work. So that's actually the target environment that we're testing this on, this one and the next things. And all of that requires that you have far less elements, so you can't really take a desktop workflow and just say I'm going to run with it on my mobile, but you actually need to think about a much more focused view, which means, again, putting one of these cells, one of these relationships in the focus, providing exactly the information that you need, and then doing like a drill down approach where, you can, for example, in this case that's shown here, you first pick the elements you want to reference. In some cases, these will be automatically picked for you. And then add potentially filters, you can add functions and define those parameters, and then immediately get feedback again from the software. Of course, this also requires that you actually have like a cloud transformation behind that, because on the mobile phone you will not want to transform your 20 gigabyte GML file, I assume. Yeah. We are also looking at how to actually display the data. So far in Hail Studio we've used more or less a conventional map client that works with display per feature type and so on. But we thought it might really make sense to look a bit deeper into what kind of data do we have there, and does it really make sense to always look at it in this kind of layer-oriented model. And we're actually working on something we currently call linked maps, where the idea is that I assume the default state to be an explorative one. So I have, for example, this river object, and I see that it actually has a reference to a catchment, so I can explore that and so on, so that I can basically find my way through the data using all the relations that we have in there. That would obviously work with linked approaches, and it would work with object-oriented models like we have them in Inspire. Yeah, and the final thing, that's for me personally the most interesting one, but it's also the one that's still a bit out, because to get this to work completely is quite a challenge, is what we call direct instance manipulation mapping. So quite a lot of engineering applications today actually enable you to work without abstractions where possible. That means you don't work on the schema, you actually work on the object. But it's still schema driven. So that's kind of the difficulty here, is to allow you to just manipulate an object. Just to give you an example, the basic pattern here is that you have your source objects on the left-hand side and your target transformed objects on the right-hand side. And to define that it should be transformed, you can basically drag and drop the objects and drop them in particular ways. So you can drop them, for example, on one of these feature types that are shown here at the bottom. So that will establish a retype relationship. And it goes on from there. So you basically have a strongly guided semi-automatic process that builds again on all the mapping projects, for example, that we already have. So we've done several hundred Inspire mapping projects. We can inform this kind of process actually with all the data that we already have to make proposals. Because in a user interface like this, it will only properly work if you basically limit the options and choices at any given point in time. Yeah. And like I said, the idea is that we don't really work on the abstraction anymore, but we immediately see what will my transformed data actually look like. And I think especially with geographic data, we really have a nice opportunity that we can show it in a nice way, compared to, let's say, for example, data from the biotech area, where it's much harder to give like an object representation where you can really manipulate representative features. Yeah, so, and that was the sneak preview part, the latter thing, I think. The other things, like I said, there are more, especially the collaboration features, so those are basically there. The cloud is there, and the next steps are going to be to really see how we can change the paradigms in which we transform data. Yep, and on the latter, I'm always happy to take user account into feedback and to find people who are willing to play with this. So let me know if you're interested.
Okay, thank you very much. Seems to me it's a clear yes to your question. Are there any other questions to this? Yeah.
Thank you, Thorsten. Very interesting presentation, very interesting views. On the cloud developments, do you expect any problems with data licensing? or data privacy even? I mean, it's an international cloud, right? Where you put
So we use the for our public cloud setup, we use Amazon in Frankfurt. And Amazon basically is one of the two providers that will give you all the certificates you want, more or less. So if you're legally allowed to use a cloud service, which not all administrations are at this point, then we basically got them covered. So there's BSI Grundschutz, there's ISO 27001 and so on. So there's several things, like also in Germany we have this nice thing called Auftragsdatenverarbeitung, which is actually not really relevant for Inspire data usually. But yeah, from a legal perspective, the answer is no, there is no problem. From a strictly technical perspective, there will never be absolute security, obviously. But I personally think that actually the security in many, let's say, on-premise installations is massively overrated compared to...
Okay, is there any other question to this presentation?
I just want to make a small plug for a session because it's relevant to the question. On Friday morning, London 2, there's a track on cloud technology. Torsten's presenting in there. I noticed there's also someone kind of addressing the data privacy, the new Data Privacy Act in the European Union. So it might be an interesting track on that, that topic.
Yep.
Okay, thank you. So if there is no other question, I want to thank the people from the organization first, then the speakers, especially for keeping us in time. We're 1 minute over. And of course, the audience for listening and taking part and putting the questions. Thank you very much and have a nice day.